Hello everyone, welcome to today's webinar. I'm Yu, Deputy Manager of the Unit of Chemistry and Biotech. With me are my dear colleagues, today's presenters, Mr. Zhefeng Chen and Ms. Rin Yang. They'll bring us some most recent updates to the guidelines of examination in the fields of chemistry and biotech. The guidelines was amended in 2019 and early this year. Both have quite a few substantial changes to the fields of chemistry and biotech. Zhefeng and Yun are our senior patent attorneys and litigators who have been practicing IP for over 15 years. They have wealthy experiences in prosecution, consultation, and post-grant procedures like invalidation and litigation. Zhefeng's practice extends from chemicals to polymers and also to pharmaceuticals. Yun focuses on technologies in biotech, medicine, and biopharmaceuticals. First, Zhefeng will shed some light on several changes in the fields of chemistry and pharmaceuticals. Then Yun will walk you through some most recent changes in the fields of biotech, sharing with us their insightful thoughts and tactical recommendation. Each presentation will last for around 20 to 25 minutes. Questions are welcome anytime during the presentations. You may type in your questions and send them to us. All participants are muted. We will have a session for question and answer after the two presentations, and we'll get back to you with the answers and to answer questions in live. Now, I will hand over to Zhefeng. Zhefeng, here you go.
Thank you, Ms. Yu. Good morning, good afternoon, and good evening. Thank you for your time to attend this webinar. I'm Zhefeng Chen. In recent years, CNIPA amended the guidelines several times, and many rules about the statutory subject matter, inventive step, and computer-related inventions were changed greatly. Today, I will introduce some most recent changes in the field of chemistry. I have divided them into three parts. The first part is about the post-filing date. The second part is about the inventive step. In these two parts, I will talk about some cases. These cases are provided in the amended guidelines, and we can understand the changes easily by these cases. Finally, I'd like to share with you some tips on these changes. During the prosecution of the chemistry applications, post-filing date can be very important. Chemistry is said to be a science of experimentation, and the technical effect of the invention need to be proved by experiment date. Sometimes we need to submit the date when responding to the office action. There is a debate about the date filed when responding to the office action. Before 2017, the examiner will reject the post-filing date just because it is not included in the description as originally filed. However, CNIPA amended the guidelines in 2017 and required the examiner to accept and estimate the post-filing date, which was submitted to argue the insufficient disclosure rejection. The guidelines did not provide whether the applicant could submit the post-filing date to argue other rejections, such as inventive step rejection, and it only provided the general principle that is, the technical effect proved by the post-filing date should be deduced by a skilled person in the art according to the information of the published application documents. In 2021, CNIPA amended the guidelines. Firstly, it was amended that the post-filing date may be submitted in order to traverse the rejections under Item 3, Article 22, or Item 3, Article 26 of the law, or others. That yes, the applicant can submit the experiment date for any purpose. This amendment enlarges the usage of the post-filing date when responding to the office action. Another important amendment is that 2 examples were provided in the guidelines. These 2 examples are provided only for the pharmaceutical applications. It is not certain whether it could be applied to the other applications, but at least for the pharmaceutical applications, we can use these 2 examples when responding to the office action. These 2 examples are very important because they tell us what kind of post-filing date may be acceptable. Let's say the first example, the claim is directed to a compound A. In the description, preparation example of compound A was provided, and the compound was specified as having antihypertensive activity. The description provided a method of testing the activity, but it did not report any date of results. In order to prove sufficiency of disclosure, the applicant submitted the experiment date of antihypertensive activity of compound A. As understood by a skilled person in art, the application is filed had disclosed antihypertensive activity for compound A, and thus the technical effect proved by the post-filing date is obtainable from the application is filed. Therefore, the post-filing date should be accepted. According to this example, we can conclude even if no experiment date about the activity of a compound is provided in the description, we still have a chance to submit the post-filing date as long as the description provided enough information as required in this first example. The second example is a similar one. The claim is directed to compounds of Formula 1. In the description, the method of preparation was described with reference to Formula 1, and a priority of specific compounds, including compound A and compound B, were prepared in examples. The compounds of Formula 1 were specified as having anti-tumor activity, for which the method of testing was provided, and the results reported by saying that the compounds of examples showed an IC50 values of 10 to 100. However, no IC50 values of compound A and compound B were provided. For arguing the inventive step, the applicant submitted the experiment date wherein compound A showed an IC50 of 15, while the compound of the prior art document D1 showed an IC50 of 87. As understood by a skilled person in the art, the application is filed has disclosed the anti-tumor activity for compound A, and thus the technical effect proved by the post-filing date is obtainable from the application as initially filed. So in this case, the examiner should accept the post-filing date. According to these 2 examples, we can find that if the initial description of the pharmaceutical application provided the preparation of a particular compound, generally mentioned its activity and a method for testing on the activity, we may have the chance to submit the post-filing date during prosecution. Inventive step is another important issue for chemical applications, especially for composition applications and compound applications. In recent years, CNIPA raised the bar of the inventive step, and in practice, we will find it is very difficult to argue the inventive step of a composition claim if all the components have been disclosed in the prior art. In addition, for a compound claim, Marcus claim, the Supreme Court provided an opinion that the inventive step of a Marcus claim should be determined according to the three-step method in the guidelines. The amendments about the inventive step are mainly based on these cases. Let's say the first amendment in 2019. This amendment is about the three-step method for identifying the inventive step. The so-called three-step method comprises the first step of identifying the closest prior art, the second step of identifying the difference between the closest prior art and the claimed invention, and the technical effect of the difference, and the final step of determining whether the prior art teaches applying the difference into the closest prior art to obtain the technical effect. If yes, the claimed invention does not involve any inventive step. The amendment was made to the second step for the technical features that are correlative with each other. The technical effect of the features and the effects of the correlation in the invention should be considered as a whole in the invention. This amendment comprises 2 points. The first point is that the relationship of the technical features may be considered as the difference between the closest prior art and the invention. And the second point is that the technical effect should be relative in the invention, not the prior art. The second amendment was made in 2021 about the inventive step of Marcus claim. The similar three-step method is established to estimate the inventive step of Marcus claim. In the previous guidelines, if the main structure of the Marcus claim is different, the inventive step is accepted. However, according to this amendment, even if the main structure is different, the examiner will consider whether this difference is obvious. It may be clearly stated in the following examples. This example is newly provided in the guidelines. The prior art provides a biocide AR, wherein R is C1 to C3 alkyl, and the prior art teaches the activity will be increased with the number of carbon atoms. For example, the prior art teaches that the activity of the biocide with C2 alkyl is higher than that of the biocide with C1 alkyl, and the activity of the biocide with C3 alkyl is higher than that of C2 alkyl. Then the biocide with C4 alkyl is obvious, even if the activity is higher than the biocide in the prior art. However, if the activity of the biocide with C4 alkyl is greatly increased, for example, 10 times of the biocide in the prior art, the inventive step may be accepted because the increase of activity is unexpectable. This example was provided in the previous guidelines. This is an interesting example. In the previous guidelines and the present guidelines, the decision is the same. The Formula 1B involves an inventive step. However, the reason why Formula 1B involves an inventive step was changed. In the previous guidelines, Formula 1B involves an inventive step just because Formula 1A and the Formula 1B have different course structures. On the other hand, in the present guidelines, the reason is provided based on the three-step method. For example, Formula 1A and Formula 1B have the different course structures, but they have the same usage. A skilled person in the art generally believes that the compounds having similar structures may have the same or similar usage. And the similar structures means that the compounds have the same core structure or ring. The prior art does not teach modifying the core structure of Formula 1A to that of Formula 1B and anticipates the same usage. So the Formula 1B is non-obvious. Finally, I will provide some tips according to the above amendments in the guidelines. This tip is about the drafting before filing the application. Firstly, it is very, very important to provide the experiment date as possible when drafting. If it is difficult to provide the experiment dates for all the compounds, the important thing is to provide the preparation examples for all the particular compounds. Let's see the question. If the preparation example of a compound is not provided in the description, would the post-filing date be acceptable? According to the above two examples in the guidelines, the post-filing date about this compound may not be accepted. With respect to the technical effects which are not confirmed, my recommendation is to mention them in the specification and to provide the method for testing on the technical effects in the specification. Then those unconfirmed technical effects may be used to argue the inventive step of the invention. This tip is about the drafting of a composition invention. As you know, for a composition invention, the components may all have been disclosed in the prior art. So according to the above amendment to the guidelines, the combination of different components and the technical effects of the combination may be described in the specification. Then the likelihood of success may be increased. Thank you.
Thank you, Jonathan. Thank you for sharing. It's quite informative and very practical. Now we come to the biotech session. Ms. Yun Yang will bring you some new stuff in this field and share with us her thoughts and recommendation. Yun, over to you.
Okay, thank you, Ying, for the introduction, and thanks, Zhefeng, for sharing the useful information. Hello, everyone. Welcome to attend today's webinar. I'm Yun Yang. I'm very glad to have the opportunity to share some updates of the guidelines for examination in the field of life science. As we all know, life science is a fast developing area. For example, the development of stem cell technical, sequencing technicals, and gene engineering to encourage innovations in this field and meet the developments. There are needs in setting and clarifying the criteria in the examination of life science inventions. There are 4 main changes in the revised guidelines, which will be the main contents that I would like to present today. The first change is about the patentability of human embryonic stem cell. The second one is about the third biological material depository institution designated by CNIPA. The third one relates to the monoclonal antibody claiming, and the last one relates to the judgment of the inventiveness of different biological inventions. The first one was revised in year 2019, and the others were revised this year. Okay, now let's see what was revised for the patentability of human embryo stem cell related inventions. According to the guideline, use of human embryos for industrial or commercial purpose is contrary to social morality and is excluded from patentability under Article 5 of the Chinese patent law. In year 2019, the guideline was revised such that under two particular certain provisos, an invention involving isolation or obtaining stem cells from human embryos should not be denied on the grounds of violating social morality. The provisos are: the first one, the human embryos used have been fertilized for less than 14 days. And the second one is, the human embryos have not undergone development in vivo. In addition, the guideline also revised to exclude human embryonic stem cells from human body at the various stages of its formation and development. Those changes meet the 14-day rule, which is an international ethic standard and a stop sign for limiting laboratory studies of human embryos, and which has been in place for decades and even written in laws in many countries. That day is the point at which a spherical embryo starts to form a body plan, deciding where its head will end up and when cells begin taking on specialized missions. Hence, for inventions relating to human embryonic stem cells, we may draft those cells according to the revised guideline to ensure the human embryos from which the stem cells derived meet the 14-day rule and no in vivo development requirement. In addition, although not expressly stipulated, according to the practice and the decision of some re-examination cases, another possible way to draft a human embryonic stem cell related invention is to define the stem cells into derived from established cell lines of human embryonic stem cells obtained from commercial sources. This is an elimination of improper tracing of human embryonic stem cells to the very beginning of a human embryo by patent examination authorities, and is considered to meet the requirements of public order and good customs. In addition, in the examples of the specification, experiments using established cell lines such as H1, H7, and or H9 cells commercially available from Cell Research Institute may be required to be presented as a support for the limitation. Next, I would like to say something about biological material deposition. As we all know, biological materials are difficult to describe with wordings to meet the strict enablement requirements. And sometimes the process for obtaining the biological materials are not repeatable or reproducible, such as by unrepeatable screening or mutation. Hence, for biological materials, not available to the public and cannot be described to meet the requirement of enablement, and the inventions are relied on such biological materials to complete or verifying the effect. Such materials need to be deposited in a designated depository institution. To meet the increasing needs after CGMCC and the CCTCC, the CNIPA further designated a third depository institution for biological material samples, GDMCC, which is also an institution acknowledged by the Budapest Treaty. From the locations of the three institutions, we can see they cover the northern part, middle part, and the southern part of China, respectively. In addition, the new designated institution in Guangzhou, the southern part of China, may also provide services to some nearby Southeast Asia countries, which may not have their own international depository institutions acknowledged by the Budapest Treaty. To make a successful and effective deposition, we need to do the right things at the right time with the right institution. Please pay attention to the time for making the deposition, submitting the certificates, proper indications of the deposition, and the selections of depository institution and the types of deposition. Since the requirements for this part have not been changed, I will not spend much time on them. However, should you need more details, please feel free to contact us. Now, let's move on to the next part about monoclonal antibody claiming. Monoclonal antibody is really a fast developing hot area nowadays. For example, according to an article in Nature Reviews, in this April, FDA approved the 1000th monoclonal antibody product. Half of the products were approved within 29 years after the first one, while it took just 6 more years to reach number 100. From this figure and this table, from this figure and this table, we can see that the antibody products are used in the treatment of various diseases and have strong commercial powers. In China, this is also a hot area, and the number of patent applications claiming monoclonal antibodies also increased sharply these years. To clarify some of the criteria for examination, the guideline has been revised to explicitly stipulate that despite claiming a monoclonal antibody by the hybridoma which produces it, it can also be specified with its structural features. A new example defining all the CDRs of a monoclonal antibody has been added. As you can see in this example, all the 6 CDRs are defined with their particular sequences recited as of sequence ID number blah blah, rather than using an open-ended wording comprising. Although this example is new in the guideline, in practice, defining a monoclonal antibody by its CDRs has already been used and accepted for several years. Despite the 2 particular ways exemplary indicated in the revised guideline, there are many different ways for monoclonal antibody claiming. For example, defining an monoclonal antibody by hybridoma producing it, by the structural features, by the binding targets thereof, sometimes features about process for preparation, the functions and all properties of an antibody may also be used. The main ways for defining monoclonal antibodies are defining the structure hybridoma for producing them, epitopes, antigens, or antigen or function. Making proper selection of the claiming ways for a monoclonal antibody invention is important for obtaining substantive protection in China. Let's see some statistical data for monoclonal antibody inventions with the different claiming way. It can be seen that over a quarter of the monoclonal antibody applications have been granted over the last 20 years in China. Among those granted patents defining the monoclonal antibody in the first independent claim by their structures, especially with VHVL or CDRs, has the highest granting rate, followed by claiming with hybridoma claims, while the granting rate for claiming with relevant antigen, epitopes, or other ways, such as functions, is very low. In addition, we can also see that defining the structures with VHVL shows higher granting rates than with CDRs. Comparing the four main ways for claiming, statistic data shows that most of the granted monoclonal antibody claims are drafted by defining the structure or hybridoma thereof, just as in the examples in the revised guideline. As for other ways, such as by defining the binding targets or the functions, the CNIPA is still very strict. However, with the development of science and technology, someday maybe these criteria will also be changed. As for structural claims and hybridoma claim, the former may cover a broad protection scope than the latter. However, the latter may define an antibody more precisely. Optionally, a patent application may include both an antibody sequence and a reference to a deposition as a way to make doubly sure that the antibody has been fully disclosed and claimed. If sequencing errors are discovered later, the deposited hybridoma for producing the antibody may save the day by providing an alternative way to claim the correct antibody. Regarding the sequence limitations about VHVL and CDRs, the granting rate of VHVL claims is much higher than that of CDR claims. However, since the protection scope of 6 CDR claims is broader than that of VHVL claims, we may try defining the antibody using the 6 CDR claims first, and then VHVL claims if possible. In addition, as we can see from the examples in the revised guidelines, the key parts are defined in their exact sequences by a closed-end way, using of rather than comprising, as just I have said, and with no sequence identity similarity, especially when it is used to define the VHVL or CDRs. Because the examiners consider even minor changes in those important regions may greatly affect the binding affinity or function of the antibody, and such claims may cover too broad protection scopes, which are not supported by the specification. As a comparison from the data show about antibody claims granted by the EPO, similar trends can also be seen. The most acceptable way for claiming monoclonal antibody before the EPO is also structural claims, among which the granting rate of VHVL claims is higher than CDR claims. However, we may also see that about 2% of structural claim defining the key sequences of monoclonal antibody with sequence similarity, identity, or homology are granted by EPO. This is different from the situation in China, so please pay attention to such a difference. We hope one day, with insight into the structure-function relationship of antibodies and with the increasing need for encouraging innovation, such a criterion in China will be relaxed. The above are some general strategies. Of course, in each case, the question of what kind of claims are appropriate may depend on the type and the substantial contents of the invention and should be analyzed in a case-by-case study. Maybe a combination of different ways for limitation can be used to protect the inventions from various aspects. Another main revise in the 2021 guideline is about the inventiveness judgment of biological inventions. The revised guideline added one paragraph to emphasize the judgment of the inventiveness of a biological invention should also follow the conventional way. That is the three-step method, as just now Zhefeng has mentioned. And in the other new paragraph, the guideline also pointed out that some special ways, such as biological material deposition, are used to characterize different biosubject matters, and multiple factors such as structural difference, genetic relationship, and the predictability of the technical effects need also be taken into consideration. The guideline further provides some examples for judging the inventiveness of inventions relating to genetic engineering, including gene, polypeptide and protein, recombinant vector, transformant, fused cell, and monoclonal antibody. You see it again. According to the previous guideline for biological invention, unexpected technical effect is the main fact that is used in the judgment of inventiveness. But now, according to the revised guideline, despite proving the invention has produced an unexpected technical effect, the judgment should also be made following the conventional three-step way first, and determine whether there is any structural difference between the biological material of the invention and the corresponding prior art biomaterial. Checking whether such a difference leads to any improved or distinguished property to the claimed biomaterial. And if there is no technical clue in the prior art about such a structural difference may lead to the improved or distinguished property, the invention is inventive. This may reduce the burden of proving unexpected technical effect. Let's take the revised part about monoclonal antibody invention as an example. According to the revised guideline, if a new monoclonal antibody to a known antigen has obviously different key structure for determining the function and use thereof to a non-monoclonal antibody, and there is no technical clue in the prior art for obtaining the claimed antibody. Once the claimed antibody produces benefit technical effect rather than unexpected effect, the invention is inventive. It can be seen that in this case, there is no burden for proving an unexpected technical effect. As for monoclonal antibody, only defined it with an antigen whose immunogenicity is quite clear in the art. It is not inventive. However, if the invention is further defined with the hybridoma that produce it and is proved to produce any unexpected technical effect, the monoclonal antibody invention is inventive. It can be seen that in this case, making further limitation to the hybridoma and proving the unexpected technical effect are both required. In summary, the inventive step of a biological invention can be judged based on the following general rules. If the biological invention has structural difference and has improved or different property, and there is no technical clue about the relationship there between, the invention producing beneficial effect is inventive. Second, if the new invention can produce any unexpected technical effect, it is inventive. 3. To the contrary, if based on prior art, it is easy to obtain or determine the contents of the invention and the technical effect is predictable, the invention is not inventive. So this comes to the end of my introduction today. Thank you for listening. I hope the invention we just provided would be helpful.
Thank you, Wing. Quite a lively presentation and also rich and practical. Now it's the Q&A session. So please type in your questions and send them to us. We'll be glad to answer any of your questions. Okay, let me see. Okay, let me see. Oh, good. We have a question from Mr. Alexandra Neville. Thank you, Mr. Neville. The question is about the post-filing data. The question is, are the two examples applicable to all fields or just a pharmaceutical? So, Jeffan, I think it's to you.
Okay, thanks, Ms. Yu, and thanks, Mr. Neville. Good questions. I think for the pharmaceutical applications, yes, say that we can use the two examples for to submit to the experiment date, but for the other applications, the guidelines does not say no or say yes. I'm not sure whether we can use these two examples. We are also waiting for the new case law or information from the courts or CNIPA. We will update with you. Okay, thanks, Ms. Yu.
Thank you, Jeffan. Let's see. Okay, here's a question. I think it's for you. It's from Caroline Jackson. Okay, thank you, Ms. Jackson. The question is, when talking about inventiveness of antibodies, you mentioned the benefit technical effect and unexpected technical effect. Then what's the difference between them? Okay, Yun.
Okay, thank you. I think this is a quite good question. And for these two types of technical effects, first, I would like to say they are both compared with the prior art. They are based on the prior art standard. For the unexpected technical effects, this technical effect for this standard is very high. The requirement for meet this unexpected standard is very high. Then maybe it can be a qualitative change. For example, in the prior art, the compound is used for anti-tumor, and in the invention, it is for antibacterial. So this is a totally different technical effect. And the other type is quantitative change. Maybe according to the prior art, you can improve the effect for maybe 2 times is a good effect. Then for an unexpected technical effect, maybe the effect will need to be increased for example 100 times. So for a skilled in art, he cannot predict or deduce from the prior art that technical effect. And for beneficial technical effect, the requirement is relatively low as compared to the unexpected technical effect. If it is made, the invention is made by two different inventive concept, maybe a similar technical effect to the prior art document is enough. Thank you.
Okay, thank you, Ming. If no more questions, I think we're gonna conclude the webinar here. So thank you very much for your interest and participation. With these webinars, we SPTL is devoted to bring you the latest news, events, and trends of IP practice in China. Our next webinar will be around August 25th. The topic will be the strategy of third-party opinion as a tool to challenge a target application before grant. So stay with us. See you next time. Goodbye.
Bye-bye.
Bye-bye.